Hello! Today we're going to keep on dissecting chemical formulas, and today we're going to learn how to compose formulas in substances of category 2. These are binary ionic compounds. What sets this group of elements apart for composing formulas? This category encompasses elements that are compounds consisting of more than one type of ion, thereby exhibiting a diverse range of chemical properties and behaviors. And in this particular case, it is customary to indicate with Roman numerals in the name the exact amount that will be charged for each of the particles, as is traditionally done. For instance, let's consider the iron ion with a charge of 3+. In this case, it is referred to as trivalent iron. If this is iron 2+, as per the given information, it will be iron and its valence will be 2. Therefore, it is a matter that concerns all elements with variable valence in their chemical properties. So, as per the requirements, you need to utilize these Roman numerals in the title without a doubt. So here's what we're going to do at this moment. Let's give it a try on some real-life examples. By the way, we will have to assemble these chemical formulas once more. And in numerous cases, we utilize a special rule. I will remind you of that. We are currently employing a rule referred to as the cross rule in our current process. And correspondingly, we make use of it in order to create formulas. Well, let's assume that we have iron with a charge of 3+ in our compound, and for instance, we have a chloride ion with a negative charge in this particular scenario, just as an illustrative example. We do not need to write down the unit. So, how will the formula be composed? Let us make it. We write the positive charge first. We cannot write the negative one first, 3+, well, and chlorine will have a negative charge. By applying the cross rules, we'll have 3 here. Here's the rule, and there will be 1 in this location according to the findings. We don't write the number 1. How will the name sound? This substance will be called iron chloride, but since iron here has a valence of 3, we must show it with a Roman numeral. And the name will be accordingly like this. Just a reminder, when there's a suffix ending in ID, it means that it's a binary compound with only 2 chemical elements. Okay, moving on to the next example, we will consider an element such as iron, which has a charge of 2+, and another element like sulfur, which has a charge of 2. With a different negative charge of gray, it will not be the case here. So what is the formula going to be? Iron in the first place, sulfur in the second place. Iron has 2 pluses, sulfur has 2 minuses. In this case, technically the rule of the cross could be applied, writing it like this, 2 and 2, but since these numbers can be reduced, in the end we have 1 and 1, but we don't write the 1s. And at that point, this particular compound is commonly known as iron sulfide 2 in scientific terminology. Due to the fact that iron possesses a valence of 2 or a charge of 2 in this specific case, it follows that this compound will also be designated by that particular name. And the suffix ending, please take a look, will be exactly identical to what is shown here. For the next example, let's examine copper with a charge of positive 2 and bromine with a charge, respectively, of negative. Bromine will not have a negative charge. Let us put together a formula. Copper is in first place, positive 2, well, bromine will come in second place, negative. And then, using the rules of the cross, we'll end up with the formula copper bromine 2. What will it be called in accordance with this? The designated name for this substance will be copper bromide 2. And the suffix ending will be exactly the same. Another instance that illustrates this point.
Let us obtain a certain quantity of tin with a positive charge of 4 units.
And let's consider, for instance, oxygen. As a result, we have 2. This will be the oxide formed by this compound. Lead is in first place with a charge of 4+, and oxygen is in second place with a charge of 2. Formally, you could apply the cross rule and write it like this: tin 2, oxygen 4. But since the indices are divisible, here it will be 2. Alternatively, you could use a common multiple and come up with a formula like this. In that case, we get this compound, which is called tin oxide 4. This is how this connection will be. No doubt it will be different then from tin oxide 2. Allow me to provide an additional example. Consequently, take the lead with a charge of positive 2+. This will help illustrate the concept more effectively, enhancing understanding and facilitating comprehension. And let it be a chlorine minus charge. All right, we write lead with a charge of positive 2 in the first place, indicating that lead has lost 2 electrons. The chlorine will be absent. Therefore, in accordance with the rule of the cross, it will transform into lead chloride 2.
By the rules, plumbum is the sign for lead.
Okay, in this particular scenario, it is 2. Furthermore, this will serve as the designated name for establishing and maintaining this connection. So please take a look. Practically in all of the examples we have completed together, the cross rule consistently works. You can utilize it. Do not forget, please, that on occasion we will have to truncate our indexes to ensure correctness. Just a reminder, you can't do things like, for example, the formula, let's say ferrum fluor 3 is correct. However, how could you possibly not write it? Chlorine 3 iron, you cannot write it in such a manner as that. It's impossible to write, for example, the formula to leave the indexes as we got them initially. So like the act of becoming 2 out of 4, that is not the correct outcome. That formula is not accurate or valid. Then the correct formula should only be stannum 04. 2, this will be correct. All other options will be considered wrong. So I hope it's clear how we worked with such formulas, what they are called, how they are constructed, such formulas, and the names of such substances. I hope you learn to give it. Probably it will be clear in all other examples that you can try to do yourself. Well, on the next lesson, we'll talk about the next category of compounds, where the formula will also be composed based on charges. Well, that's all for today. Goodbye.